Okay, we're going to do something weird, and it might make you a little bit uncomfortable. But we have to do it. This is what we call a unit circle. And what a unit circle basically means is that the radius is 1, right? Any direction you go. Oh, well, yeah. Ow. The radius is always going to be 1. Well, yeah, because it always has to be 1. Otherwise, it's not a circle. So the radius is going to be 1. So any point on this is going to be exactly a distance of 1 away from the origin. So this point right here is 1. This point right here is going to be 1, comma 0. This point right here is going to be 0, comma, no, not negative 1, 0, comma 1. Right here would be negative 1, comma 0. Right here would be 0, comma negative 1. So it has a radius of 0. Of what? That's what a unit circle is. A circle with a radius of 1. Now, if I were to draw an angle right here, and yes, we're going to talk about SOHCAHTOA because if I were to draw an angle, let's say this is the first part of my angle, goes like that, and then I draw another angle that goes like another line that goes like this, and I have this angle right here. Now, imagine I were to draw a line down to the point where it intersects. Okay, I have just made a right triangle. What? Now, let's talk about SOHCAHTOA. Using this right triangle right here with this unit circle, what would be my trig identities? Okay, so I have this angle, it's opened up on the circle, and I want to know my trig identities. Well, sine, let's start off with sine first. Sine is equal to opposite over hypotenuse. Opposite over hypotenuse. So in this case, what is the opposite? We have this angle right here. What is the opposite for this angle? And it's going to be this wall right here. Now this, the length of this is going to be equal to whatever y point that this line right here has intersected whenever creating that angle. Whatever y point this is right here at this line intersecting, we'll call that y point B. So we'll call that length B. So it's going to be equal to B. And the hypotenuse, since the radius of this unit circle is just 1, this intersection point right here is just going to be this line. This length right here is just going to be 1. So sine is just going to be equal to B. Okay. So sine is going to be equal to B in this scenario. It's just going to be equal to B because the hypotenuse is always going to be equal to 1 if we take the length from the point that it intersects this circle. Okay, but what about this right here? What about cosine? I mean, cosine. Cosine is equal to adjacent over hypotenuse. The adjacent side for this angle is this right here. And this is going to be equal to the x-coordinate. This x-coordinate, it's where B lies. B lies right here. Or the x-coordinate at which this line right here, the straight line, the hypotenuse, intersects with the unit circle, which is going to be of length, I don't know, A. We'll just say A. It's going to be of length A. Because we don't know. Because it could go like this. If the line was up here, it would be right here. We wouldn't know. So A is going to be equal to A for the hypotenuse. But the hypotenuse is 1 since we're measuring it from where it intersects with the unit circle. And the unit circle radius is just always going to be 1. So the hypotenuse length is always 1. So With this, whenever we look at it like this, and we look at the triangles, and if we were to keep the right triangles bound to the fact that it has to the b the adjacent or b is going to be equal to the point where the y point where the hypotenuse intersects with the unit circle. If we keep the rules like this, where we do everything based on this unit circle, we have that sine will always equal b, or in this case, y as is going to equal y, which is going to be at the point at which the hypotenuse intersects the unit circle. So if it intersected the unit circle, we were to draw another line like this, sine would now be equal to this y point right here. And x will be equal, and cosine will be equal to x, at which the point that the hypotenuse intersects the unit circle. So it would be equal to, if it intersects right here, it'd be equal to this x right there. And what would tangent be? Well, tangent would be tangent would be well, tangent's equal to, I explained in another video. The tangent is equal to sine over cosine, which is equal to y over x, because we're going to be defining, whenever dealing with this unit circle, we're going to be defining as sine is equal to x and cosine is equal to y, at which the point the hypotenuse or the angle intersects with the unit circle. And we do this because mainly that if we keep the standard definitions, then we have a problem whenever we get to negative numbers and angles larger than 90 degrees and stuff like that. So yes, whenever dealing with the unit circle, this is how we're going to define sine, cosine, and tangent. So yeah, stay in school, and that circle is not as fat as your mom.